Hey physics, here we go again. I'm going to set up the most complicated circuit I have yet. This is the third one in this little series, and I should have plenty of resistors in it, so let's not waste any time. Let's get started. So it's going to have a start and an end, just like always. However, lots of resistors in the middle, so let me go ahead. I'm going to do something to save a little bit of time. I'm going to draw the resistors themselves in black. I'm going to label them in colors. Okay, so we got many resistors. Oh my goodness gracious. Okay, so that's 1, 2, 3, 4, 5, 6, 7. 7 resistors. That means I'm going to need 7 colors. So starting out, we will have resistor 1. Another way to save myself some time, everything here is a resistor. Every single unit is resistance in ohms. So I'm just going to write the number and not worry about the units. Okay, so I've got here, let's say 600. So let's keep the red around. Next up, orange. This is going to be R2, and that can be 1000, so 1K. All right, let's keep that around. Next color up is going to be R3. R3 is this poor guy down here. And R3 is going to have a resistance of 400. Okay, moving on. I've got kind of a bluish green, greenish blue, whatever it is. So this is going to be R4, and might be a little close. R4. Let's go ahead and make this one be 700. Okay, thank you, bluish green color. Let me go nice deep blue. We can go R5, and R5 is going to be. What's R5 going to be? R5 can be another 1000. Okay, 1K for 1000. Okay, I just need 2 more colors, and I'm going to go ahead with, I'm going to keep these nice and distinct. All right, so I've got I think I can keep these separate, purple and a maroon. So let me put the maroon here as R6. And this one, I haven't had an 800 in this one, so let's go ahead with 800. And last resistor here, R7. Oh, let's see. 600, 500. That's the one I need. 500. Okay, so I've got 7 resistors with 7 resistances. R1 is 600, R2 is 1000, R3 is 400, R5 is 1000, R6 is 800. Oh, did I skip R4? R4 is 700, R7 500. Okay, let's find the equivalent resistance of this circuit. So what I want to do is analyze this from the point of view of electricity trying to pass through the circuit and having choices and being forced. So one possible path that the electricity could take is to start here and then just immediately take that turn and then go around and be done. So these are a possibility. But if instead you went straight, you could take that path. Okay, so this one is not mandatory. You can take a path that does not lead you through this. This is in parallel with some others. For example, you took this one instead of that. That means that these two are in parallel somehow. You took this one instead of that, which means that these two are in parallel somehow. Now, what's funny is, no matter which way you went, though, you took this one and you took that one, which means that you could conceivably think, all right, maybe it's something kind of like this. I got this one at the beginning and this one at the end, and some mysterious one that represents this whole thing. And you'd be correct. There is some thing that you can replace this with, this group over here, and that's really the challenge. So looking at just that part of it, okay, you've got some choices that you can make. These two are in parallel, those two in parallel. What about these two? Well, you can't go through them both. You have to make a choice. So yes, they are in parallel. Okay. What about these two? Yeah, you can't go through both of them. They are in parallel. But these two... See, there is a path that takes you through both of those. So are these in parallel or are they in series? That's not quite looking at it right, because that would be breaking the order of operations, so-called. What you need to do here is find that this is a fork inside of a fork, so that this has those two in parallel. The idea is that you could take these two and replace them with a single resistor, so that you'd have three of them in a row. Tell you what, instead of describing it, I'm just going to go ahead and draw it. So let me get another piece of paper ready here, and let's go to it. Remember, I'm not going to keep this picture, up all the time. You're going to need to keep it in your notes or something. Okay, so let's draw it with that replaced. Oh boy. Redrawing. It's lots of fun. I haven't even used the calculator yet. That's how fun this problem is. And you're thinking like, yeah, but using a calculator isn't fun, Mr. Estes. And you know what? We're just going to have to agree to disagree on that. Yeah, that's right. I think using a calculator is fun. Do you know what else I think is fun? I think that saying a bunch of stupid random stuff, so that you're not just looking at my face thinking hard while I'm trying to draw for like a couple minutes, is just dead air. It's bad. All right, so I'm going to take resistor 6 and resistor 7, and I'm going to combine them into one resistor. Now, you know, they are in parallel. It's 800 and 500. So, eyes on the calculator, not on the paper falling from the sky. Eyes on the calculator. I've got 1 over parentheses, right? 1 over 800. Well, didn't really need parentheses now, did I? Plus, but I did them, so I'm going to keep doing them. 1 over 500. Okay, well, 307.7. This is going to be the first replacement, 307.7. Okay, and just to fill these in, this is resistor 1 at 600. That's a terrible 600. Resistor 1 at a completely illegible 600. I feel like I'm having an auction. Resistor 2, 1000. Can I get anything higher? I've got a, let's see. Oh, I'm all done with resistor 6. I can put that color away. I've got a resistor 3 at 400. 400, and let's see, who else do I have here? I got a resistor 4 at 700. 700, that's resistor 4. And down at the bottom there, so I'm finding that I'm having trouble writing these numbers so small into this space. I might need to reconsider my format, because this is a problem. R5. Do you know what I really wish? I wish I could get my calculator underneath my face instead of next to it. I might have to find a different calculator to use. Anyway, so now look at what we've got. You only have one fork, and you could go straight and take those 3 in series, or you could turn here and just take that one, which means these 3 can be replaced with a single resistor. I have a 700 in series with a 307.7 in series with a 1000, and I get 2007.7, a handsome number. So let me redraw this again, and I think this should be the last time I have to, no, I'll have to redraw it one more time. So right, so this is now off the screen. 2007.7. This one is my red resistor 1, 600 orange resistor 2, 1000, and green resistor 3, 400. So this is the scenario I'm solving now. So I should be able to do this in like one more drawing, I think. So let's go ahead and do that. All right. Well, the 1000 and the 2007.7 are in parallel. Just look at those, right? Those are in parallel. So I've got to add them up in parallel, 1000 and 2007.7. 1 divided by, and then the parentheses. Oh wait, I don't really need that in this calculator. 1 divided by 1000 plus 1 divided by, what was it? 2007.7. 2007.7. 667.5. I wonder if that was going to be like 666.6 repeating, except that I rounded a couple steps before. Wouldn't that be awesome? Okay. Yeah. Let's draw it. So that is 667.5. Oh, man. 600, that's R1. And 400, that's R3. Add them up. They are in series, and then we're done. So let's just take this, add to it 600 and 400. That's a final answer. 1667.5 ohms. Okay. That's how you solve a big circuit like that one. Anyway, there's more to circuits than just finding their equivalent resistance. I mean, there's Ohm's law, right? There's other calculations that you can do, but all of it requires finding equivalent resistance as a backbone. So I'm going to just leave it there for now. I'm going to wait until we're good at finding the resistance in circuits before we do anything else. So keep practicing this. Send me questions and pictures and stuff. And yeah, we're going to get this. We're going to get this.